Cool. Well, thank you all for coming out today. We are going to have what I think is going to be a really interesting conversation about the path that the folks from Wikimedia have gone through in bringing their data set into production. And so I'm really looking forward to this conversation. Glad to have Lydia and Philippe from Wikimedia here with us, and Eric Pounds from NVIDIA to bring the point of view of what NVIDIA has been doing to help make this possible as well. So why don't we do some introductions just to start. I'm Ed Anoff, Chief Product Officer of DataStax, and I'm moderating this panel of a great set of folks. So Lydia, you want to introduce yourself?
Sure. Thank you for having me. Hello, everyone. It's a pleasure to be here. I'm Lydia Pincher. I'm the portfolio lead for Wikidata at Wikimedia Deutschland. And I've been with Wikidata, the project we're talking about today, since its beginning 12.5 years ago.
Wow.
I'm Philippe. I'm the AI project manager at Wikimedia Deutschland, and actually joined the team very recently and been focusing on working with DataStax to work on the vector database.
Hi, and I'm Eric Pounds. I lead product marketing inside the Enterprise AI Products Group at NVIDIA, and I've been at NVIDIA a little over 5 years.
Cool. So Lydia, tell us a little bit about the nature of Wikidata and what you folks have been doing. Right.
So a lot of you might know Wikipedia, but maybe not Wikidata. So Wikipedia is Wikipedia's not so little sister. It's a knowledge graph that holds data about the world and everything that you could imagine being in a Wikipedia article and more. So for example, for Las Vegas, it would have stuff like it's a city, it has so and so many inhabitants, and so on. And all of that data is available, machine readable, and in over 300 languages. So Wikidata is an extremely multilingual project. The data in Wikidata has been collected and is being maintained by an amazing community of over 24,000 people who contribute to Wikidata every month. So people like you and me, who make sure that the world has access to basic data about the world to build amazing applications. And Wikidata is the most edited Wikimedia project. So those people who make up the Wikidata community edit Wikidata several hundred thousand times per day. So it's an extremely fast evolving data set. And with that come some challenges for the project we will be talking about here today. But I will leave that to Philippe.
Cool. Well, Philippe, you want to jump in and elaborate a little bit on that? Because you guys are doing some really unique use cases of Gen AI on this data, but some unique challenges around it, right?
Yeah, absolutely. I mean, as Lydia mentioned, Wikidata gets around hundreds of thousands of edits per day, which is very challenging to handle. And we would like to have the vector database also up to date. And with all these edits that we're getting, we want to re-embed them and make sure the vector database is up to date and accurate for people to use. And it's challenging, and as we were getting into the project and trying to find a solution, we were going into a solution that is more local, running the embedding models on our machines, and we found that embedding the entities, around 10 million entities, it took around 30 days to be able to do that, which is a lot. But with DataStax and with their platform, we were able to go from 30 days to 3 days, which is amazing, and it's making the project possible for us.
I mean, this is a dynamic. It's one of the largest dynamic knowledge graphs in existence, right? I mean, it's continuously edited. So when if you have something that takes 30 days, it's a non-starter. I mean, I'd imagine even within, with a 2-day turnaround, you're still looking at figuring out how to build pipelines and so on around that.
Yeah, exactly. I mean, it is challenging to be able to handle all these edits, but we're improving and we're trying to make the pipeline even faster with the support of DataStax and all of the technologies all of the algorithms and technologies that keep on improving in the platform, and we're very happy to be able to benefit from all these, the efficiency and the speed that they provide us.
That's very cool. Eric, as you've seen a lot of use cases out there. Obviously, NVIDIA has the vantage point where you get to see a lot of the things that people are trying to apply Gen AI to. How have, as you've looked at what Wikidata is doing, and obviously part of what's made this real-time process around it possible has been applying a lot of the innovations that NVIDIA has brought to the table. What are some of your thoughts as you take a look at this?
Well, I think, Lydia, you talked about the amount of data that is in Wikidata as well as the change rate of that data. And often when you're working with that much data, that's where an accelerated computing architecture can shine. And at NVIDIA, we're very much focused on accelerating workloads that are very, very compute intensive. But one of the challenges with accelerated computing is it does require full stack innovation. So a lot of people think that, oh, well, if I want to leverage accelerated computing, I just swap out this traditional server with one that has GPUs in it, and that's only one piece of the puzzle. These data centers being architected differently. Networking is a very key component, as it's not just one computer doing processing, it's a whole network of computers doing processing. It needs fast access to data, and so the connectivity into the data network is also super important. But it's full stack innovation. So the work that's done at the operating system layer and at the application layer, this is where what you've done at DataStax with the DataStax AI platform and integrating all of that in, the work that we're doing together, your users and your customers will just be able to kind of take advantage of that as one of the goals and have access to the AI tools. When it comes to use cases, it really boils down to data intensive use cases, and this is across many industries. Like even if you look at your organizations or your companies that you work in, and then you think about, well, what if I could tap into the knowledge of all of my data? You've made investments on storing this data, on ensuring it's active, it's right at your fingertips, but really gaining real-time access to all of that knowledge, that's a big data and a big processing challenge, and that's what we're focused on together.
Makes a lot of sense. I think one of the really interesting things that I personally am really excited about has been the fact that knowledge management and navigating these knowledge bases and graph-based knowledge is now at the forefront of what we're applying this computing technology for, and I think that it's the basis of really sort of how people operate today, which is in a knowledge-rich environment. We're getting to this stuff in a real-time way is absolutely essential. So I really like seeing the fact that all of the innovations of NVIDIA are being applied to use cases like this. I started my career in doing content management and knowledge management stuff back in the 90s and early 2000s. So it's great to see that evolution. Talk to me a little bit about the challenges of implementing a system like this. Like we're seeing a lot of folks who have been stuck in their RAG systems and their content and knowledge ingestion and have been building these things. In some cases, they're at it for up to 12 months in terms of things like that, trying to get to accuracy, trying to get these systems in place. You had from my notes here, close to 10 million entries that had to be, imported and managed. So talk a little bit about that process. How do you, operationalize something like that, and how do you know, what are your measurements? What are the core ways that you know that this is ready?
Yeah, I mean, the 10 million is also like one small part of Wikidata, which is like connected to the English Wikipedia.
Yep.
So it's going to be even bigger than that and even more challenging. But yeah, one of the biggest challenges that we're facing is speed and being able to set up the vector database in efficient time, but also being able to query the database for people to access it and build projects on top of it, because if it was slow and not reliable, then people will just not use it. So yeah, the ingestion process is a bit slow because from our side, it's not super straightforward because Wikidata is a knowledge graph, and being able to aggregate all this information, and per entity we would need to go through the edges in the graph and aggregate all the information and then transform it into a text representation that makes sense for the embedding model. So all of this takes a bit of time, particularly with Wikidata having around 114 million entities currently. Yeah, so this is one of the big challenges, and doing that in multiple languages. One of the other big challenges is after doing the transformation, we would want to, of course, embed and push the data to a vector database. And yeah, as we said, that process was taking 30 days for 10 million. So for 114 million, that would be crazy. But yeah, with DataStax and the efficiency, scalability that they offer, we are able to do that in a faster way. And yeah, I mean, without the speed, we wouldn't be able to create the project.
So what does that data pipeline look like? You've got, from an ingestion standpoint, I'm sure many of the people that are interested in this topic and are watching this interview, they're probably grappling with some form of that. But break it down a little bit as to what goes into that.
Yeah, so from our side, I had to work with a Wikidata data dump, and it was zipped. So it was a bit difficult to go through all the entities inside it, and had to read it multiple times to aggregate all the data and filter out one of our current tests, which is focusing on English language. So that's the first step of aggregating and transforming into text. And also the transformation is not super straightforward because it's coming from a knowledge graph. So we're trying to test out different ways of doing so. And yeah, after doing the transformation and having text representations of each entity, it's as simple as just pushing the entities to the vector database, and with the framework from DataStax, it makes things way easier.
So there were some pieces that were, so just as people sort of calibrate this with their own vector retrieval projects. So the good news for you was that you were dealing with native metadata-rich textual data. So a lot of folks who are grappling with this are dealing with things that are perhaps rendered into PDF and so on, but you've got the original source content. The challenges, of course, you still have issues like chunking and so on to grapple with, and what were some of the implementation approaches you took on with that?
Yeah, for the chunking process, I tried to make it a bit specific for our test case, and In our case, for each entity, we have, like in Wikidata, we have a label, a really small description, and aliases for the entities. And then the rest of the data is comprised of the connections in the graph. So we call them claims, which are either connections to other entities or to values and so on. And you also have like references to the data in Wikidata. So for the chunking process, I find that the labels descriptions are like really important to define what the entity is, but then the rest of the data can be split into multiple chunks. So if we have an entity that is large and doesn't fit the embedding model, then we split it in the claims or the connections level, and then we keep the labels and descriptions for all the chunks.
That makes a ton of sense. Lydias, you've looked at the project. The goal for this is to really be something that is going to support a number of different use cases. So you're really building this is really a knowledge platform approach. What have been some of the ideas that, as you've looked at this, that you've thought about that you want to be able to serve and address?
Right. So from a Wikidata point of view, for us it is very important, as you said, to be this knowledge platform, right? To provide people with the data to build amazing applications, services, what have you. And today people are building applications with generative AI. So this is one of the ways how this vector embedding, how we want to provide that so people can use it to build generative AI applications. And one of the things that's really important for Wikimedia is, of course, bringing information to the world that's reliable and trustworthy. So for all the data, or for a lot of the data that is in Wikidata, you have references to be able to say where the data is actually coming from. So that, for example, in a chat application, you as a developer who is using that embedding can also go back at the end of the day and say like, okay, this is where this data is coming from. So your users have a sense of trust and in the system and know that what they're getting is not just some random hallucination from a system. Right? That is really important for us. And at the end of the day, over the 12 years that Wikidata exists, we have seen again and again is that people come up with stuff that we hadn't even thought of, right? Like we provide the data and the access to it, and people run with it, and that's really cool to see.
Yeah, that was one of the things that I know excited us at the DataStax team when we looked at this. We were like, Wikipedia is and the Wikidata is such a foundational knowledge set for almost everything that happens online, and so being able to unlock that in these AI use cases is really exciting. Have you started to see any interesting ideas that have come along on this? Like what have been some of the things that people have been raring to go with on it?
Yeah. So there's a bunch of stuff that people are talking about, but two things to highlight maybe that people are doing with generative AI around Wikidata right now, or experimenting with is, one is our editors need support in their day-to-day work, right? And so one of them was rather tech-savvy, went and used the large language model to look at the different changes that people are making on Wikidata and try to determine, with the help of the large language model, is this likely to be a good contribution to Wikidata or rather not, and maybe another editor should look at this and see if it should be undone. And I thought this was a really cool way to use a large language model to support the human work that's happening on Wikidata. Another thing that people have been doing is Wikidata, you can query it with a graph query language called Sparkle. And it's a rather elaborate language that not all of our editors understand and are able to write, and no shade. It's not easy, right? So a team at Stanford went and used a large language model to basically make it easier for people to write Sparkle queries by just letting them formulate a natural language question, like what are the cities, the largest cities with a female mayor, and it would transform that into a Sparkle query for them that they can run on our Sparkle endpoint. And stuff like this gets me really excited.
That is very cool. That is very cool. I think that anything that can open up the data sets for more users, and again, I think that's, it's interesting you would bring that up. We see a lot of, it's one of the more interesting applications of Gen AI is, and large language models is essentially, we think in terms of vectors and vector similarity, and that's pretty powerful, but actually building complicated queries, building things like Sparkle, being able to build, being able to build a REST API query, being able to build a SQL query, being able to build a Cassandra query language query, it really provides this means for being able to make it much more possible to get at this data, even just from a query, even if the result set isn't a generated or synthesized result set, even if it's just finding that right document, it's super powerful. So that's very cool. That's very cool. Eric, one of the things we hear over and over again, from Philippe and Lydia, is that a lot of this, the big piece of the game changer is the fact that that we were able to see some order of magnitude performance increases. Is that a way that, it's interesting that the way that the experience changes from a performance standpoint, that the experience can be fundamentally transformed. Is that something that is that the way that NVIDIA sees it? Has that been something that?
Oh, yeah, most definitely. I think on one part, Philippe, that you were talking about is just the time it takes to process data and transform data, extract knowledge and data, chunk up the data, feed it into these embedding models, and being able to put it in a format that can quickly be recovered in real time when an application is running. We want these applications to behave really well. Some can be processes that run in the background that take some time, but a lot of these AI-powered applications have some human intervention, and with that we want the right behavior. We want it to feel good. So I think each step of the way, each step of the pipeline, we want to, we're trying to accelerate it as much as we can. One, to ensure that it behaves well and you can accomplish what you need to accomplish, but also drive out as much cost as possible. If you're processing a large amount of data and it's not going very fast, well, one option is you just throw more infrastructure at it, and that can get really expensive. That's one of the value props of accelerated computing, is accelerate it not just 30% or 50%, accelerate it 5x, 10x, 100x, and you can not only do things you couldn't do before, but it fits within your budget of that project or that application. The other thing I wanted to quickly mention was you're talking about processing the data to gain access to kind of this knowledge, and data. The data that we use every day lives in many different forms. So there's also there's a lot of great research going on to get access to all types of knowledge, not just knowledge that exists originally in text form, and you're taking knowledge out of a knowledge graph, or out of imagery and videos and all types of different formats that are in the world of medical and sciences and things like this. There's a lot of knowledge that is embedded in there, and being able to process that type of data, to extract that, then feed it into these into these new types of databases it will unlock so many different possibilities. And then being able to keep up with that change rate of data. I think that's the other thing with data, is that we want to be able to build process in a way that allows you to actually capture more data. And this is what's going to be kind of the start of that, that data flywheel, is that if you can process the data faster, not only will you be able to gain more insights from the data that you already have, but you'll also now be able to capture more data and more knowledge, and that will make your organization, your business, even more intelligent.
Yeah, that tees up some the next question, which is, we have been talking a lot about textual data, but how are you looking at, obviously, Wikidata has a lot of non-textual data as well, and the multimodal data question. How are you thinking about that in your roadmap? Is that something you're going to be able to open up? And what are you thinking along those lines?
I mean, we're still starting with this project, still evaluating the textual process of it.
Yes.
So yeah, I mean, like looking into the audio or images that are in Wikidata would be super interesting to do some project on top of that as well. But for now, for the next year, we're looking into like focusing on the textual data, which is the majority of the data, and focusing on like making it multilingual. And yeah, we'll see where things go from there.
Awesome. Very, very cool stuff. I think this has been, we've been very honored to be part of this project. The idea of being able to democratize this data and being able to accelerate your process and make it possible for this to be foundational for a whole set of applications, I think is something that, as I said, is very exciting to be part of. We also think it's a great template and for how many of the folks, hopefully, who are watching this presentation and watch the videos and so on afterwards on it, it plays into a lot of the themes that are important to us, which are how can you go and get leverage out of your data assets. So I love this idea of turning data into a platform from a Gen AI standpoint that you can then leverage across multiple projects. I think that's something that again, we hear from so many people. One of the things I did want to talk a little bit was just about the general architecture. We've talked a lot about the vector database as a component of it. The stack for building these types of apps obviously has the data pipeline. We leveraged a bunch of components in the process, both from DataStax and NVIDIA and others on that. Would love to talk a little bit about that just as sort of the final thing to touch on in this panel, because I think a lot of the people who are going to be paying attention to this are builders who want to try to do similar things. So we talked about the ingestion stage. We talked about in the vector database is obviously a very important component of it. And then from a querying standpoint, is the idea to layer, to do the Sparkle, continue to do Sparkle queries against that? You're also making natural language. Will people be able to do general vector queries against it too? And
I think at the end of the day, we will have to see. Also, how people will pick it up, right? I do believe that Wikidata absolutely needs to continue to offer other ways of getting to the data that are not a vector embedding or not a generative AI, simply for much simpler requests and things like that. But yeah, I think long term it will become a part of what we're offering. And then things like chat interface and so on, I do believe that others should be able to build that on top of what we are providing rather than us building that ourselves, I would say.
Yeah, from our end, we definitely want to be able to leverage it for people who are building applications within Langflow, for example, to be able to have a Wikidata component that they can plug into their agents and so on, for bringing that knowledge into their agentic systems. Eric, one last question for you on that. As you listen to all these things, and NVIDIA brings a pretty rich suite of components that are part of the AI enterprise to this. What are some of the pieces that as you hear all this that you're excited about going forward that are interesting and applicable to this?
Well, I think that you brought up Langflow and a bit about where things are going. This data is going to be the fuel for these AI agents, and these AI agents are going to help all of us be more efficient in what we do. Allow us to focus on higher level tasks. Allow us to automate things that can sometimes be repetitive in our lives. And we're all going to have many agents or assistants helping us out, and the fuel for that is data. I know the work that we've done together on the DataStax AI platform, and the work that a lot of it's still in front of us, and is making it. I'm looking forward to making it easier for everyone using DataStax to not only be able to connect to data but also then improve the applications as you go, as the applications learn, being able to customize the models in the platform.
Right.
Customize improve the embedding model, improve the re-ranking model, improve the primary LLM, make the agents smarter or more tuned to your use case or your application. It's in a lot of these scenarios, it's not going to be kind of one model does everything. You're going to tune them for each agent's going to have a personality, and you're going to tune these models to best fit that use case, and that model is going to learn as it lives its life. Just like as we do our jobs, we're continuously learning and evolving. These AI agents will be the same way. So the work that we're doing with you to leverage some of the investment we're making in our NEMO platform for not just information retrieval, but for model fine tuning and evaluation and guardrailing and so on and so forth, and then be able to deploy that in a way that you can run it at scale. It was really exciting to us, and just being able to have access to those in a platform is super valuable. We're all making a lot of contributions to open source, and a lot of these pieces are out there. But for most teams, if you have to essentially productize it yourself, it's going to be challenging. So these platforms coming together are going to be super valuable to enterprises and organizations all over the world.
Yep. Yeah, I agree. That's some of the things we really like about what NVIDIA has brought. Obviously, fine-tuning within RAG systems is proving to be extremely effective. Being able to make sure that you can do things, through continuously improving your models and such. And then obviously, if you are providing any sort of public-facing service, being able to do things like having an effective guardrail service built in is very helpful on both pieces of it, both in the Wikidata case where you've got a large amount of content contributions, being able to go and detect and fingerprint content that people are putting in probably helps your moderation process considerably. And then just once you're making it available, again, being able to make sure that the responses aren't going off the rails with your guardrail system. So a lot of cool stuff here that I think is going to be very applicable to a lot of people in their Gen AI journeys. We do have some time left, so I think it would be great to be able to take any questions people have. If anybody has any. Unfortunately, with the lights on us, I can't see, so somebody will have to tell me whether we're going to take any.
I have a question.
Awesome.
Once you loaded all the data into the vector database, how did you test that the results were what you expected? How did you test that it actually worked?
Yeah, let me repeat the question, which was, once we loaded all the data into the vector database, how did we test the results to make sure that we were getting accurate results and what had, that basically the loading and chunking had happened correctly?
Yes, for sure. So yeah, to be able to evaluate the vector database, see if it's accurate enough, if it's working as expected. We would need like an evaluation data set that from one side has like user queries or questions that are also connected to Wikidata entities and entities that you would expect the vector database to return, whether they have an answer to the question in them or they're relevant. So once we have that data set, we can simply query the vector database, get a list, and compare those two lists, see if they match or not, or if they're close enough. Yeah.
How long a list are we talking about? I mean, give us a little bit more details on that testing process.
Yeah, I mean,
How long does it take to run? How it's, you know, what?
you would want to like try to simulate what you want to do like in the application itself. So let's say if you want to do an application that returns, or like a RAG application that returns 10 items from Wikidata, and you want to give those 10 items to the large language model to augment, you would want to have at least one of the items be relevant, ideally more, of course. So yeah, we would want to evaluate based on that. And also it depends on the evaluation data set, how many items they have that are relevant. Yeah, it's not as intuitive, but once you have like these values and you can compare different algorithms, you can see like, okay, this algorithm is the best and values are high enough, so it's good to, yeah, eventually have these metrics to like compare. And yeah, from our side, it's luckily since Wikidata is open source, there has been a lot of research and data sets out there that has been created for that case. And there's, for example, one data set called Mintaka that is actually developed in Amazon. And it's perfect for our case because it has like a lot of different complexities for the questions. So it allows us to evaluate the vector database on different, yeah, difficulties, let's say, from the RAG system. And also it's multilingual, so it's allowing us to evaluate the vector database on if it's working on multiple languages and things like that.
Very cool, very cool. So you were able to leverage the work that researchers had done previously on these things, so you didn't have to construct them from scratch.
Yeah, exactly.
Very nice. Cool. Do we have another question? I think we do.
How important is data sovereignty for you and to process the extraction where you keep the data?
The question was about data sovereignty. Do you want to, Lydia, do you, or?
I'm not sure what that is.
So, figuring out where the data sits for the locale that it's served from. Let me turn it back into.
So like
yes.
GDPR compliance
Yes.
versus
Right.
it has to be in country versus it has to be
yeah.
behind a firewall.
Right. So Wikidata's data is contributed from all around the world under CC0, and community processes exist that the data we collect is not infringing on personal rights and so on. So the average person is not in Wikidata and their data, right? It's usually very famous people, and it's data that is available already in other places that our editors collect. So in that regard, the community processes on Wikidata itself make sure that the data we have is clean, so to say, and in good shape. Is that what you were getting at? Or?
Probably the question coming from a data sovereignty standpoint is, do you do one global data set, or do you have, for example, if in GDPR where you have right to be forgotten, for example, do you maintain a different version? This is some of the challenges that the search engines do.
Right. Yeah. So there's just one Wikidata.
Yes.
That is available to everyone, and it's all hosted by the Wikimedia Foundation alongside Wikipedia, and yeah, there is no separate data set that we get in Germany or here in the US or somewhere else.
If I understand correctly, like, do you mean if we're searching on a different part of the world, you would get different results than?
Yeah, that's one facet of it. So this is just one of the things that we do see a lot of companies that are serving content in different geographies. There are a myriad set of rules that address what you can provide under what circumstances, and there's various approaches to how you deal with that. And so I think that was the essence of the question, which was, have data locality or data sovereignty issues been a concern? You've designed this to be servable in most regions in the world, and
yeah. So this is the stuff that the Wikimedia Foundation takes care of, hosted in the United States with rather favorable laws for the encyclopedia and the knowledge graph.
Yes. And I would say, like, from the vector database side of view, I mean, from Wikidata, we aim to make the data and the knowledge accessible to everyone around the globe. And from the vector database part of it, we aim to have like an embedding model that is multilingual. And if someone wants to search like a query on one particular language, you don't have to get responses of entities that has this language. We're trying to create like a vector space that encapsulates all these languages. So yeah, you can search in one language, get an answer in another language, and yeah, make it more accessible to everyone and global.
I think I see another hand up.
One of the components you mentioned using is the NVIDIA reranker. Can you explain what's the purpose of reranking?
Yeah, the question was the NVIDIA reranker, and talking about reranking.
I can just say a few things, then you can take. I mean, essentially, it's when the data comes out of the database, it's essentially doing one more pass to put that in the best probable order of aligning to what you're looking for. So when that data then gets fed back into the large language model with the augmented prompt, it will produce the best possible, the most accurate result. I don't know exactly how you're using re-rankers in your pipeline, but.
Yeah, we definitely want to like test out different re-ranking models and like see how the accuracy changes with those models. But yeah, re-rankers basically, I mean, when you're creating a vector database, you're creating the embeddings of item in Wikidata regardless of what the question is, so completely separate. And when you're getting these items, when you're retrieving the items, it's not going to be super accurate. The re-rankers, what they do is they take the text from the entity and the question, and they give you like a score of whether these two are relevant to each other or not. Of course, it's way slower than the vector database, because if you're getting a question, you don't want to like go through all the items and do that scoring. So you want to have both these solutions, the vector database for speed and getting like a first initial set of items that are relevant, and then the re-ranker to basically re-rank the items and based on the relevance and see which ones are best to answer your question.
Great. I think that I don't see any more questions. So any last thoughts for that I'll turn to each of you, for folks that are thinking about these types of projects, and if there was one piece of advice you could give for somebody that is trying to do a large-scale knowledge retrieval project or RAG project, what would be the first thoughts that come to mind? I'll let Lydia let you start.
I think I would say have a look at Wikidata and all the data that already exists there that's available to you. as basic knowledge about the world, and that can open up a lot already for you.
I would say if you want to like start a project, particularly in rack systems or AI, like think about what you want to achieve first and what your goal is. A lot of people just want to like create AI projects and they don't really know what they want to, like what the end goal is. So if you don't have that, then you're not going to create a successful project. So have an end goal and know what you want to reach at the end.
I'll just say that you'll learn a lot through doing. So I highly recommend jumping in 2 feet first. Don't watch this train pass you by, and think about yes, how you can leverage the data that's available to you, the public data that's available to you, as well as your proprietary knowledge that is essentially, your businesses or your organization is encoded in your data and your proprietary knowledge. Figure out, what's the best data to first tap into and go right at it and unlock that data and leverage it. And I think you'll learn a lot along the way, and you'll adjust in advance, and I think it'll benefit your organization.
Amen to that. Yes. So thank you all for joining us. I think that these are great pieces of advice. Begin with end in mind. Think about the application that you're delivering. Make sure you've got the right stack. Make sure you know how to evaluate your results. And if you do all these things, I think the ability to unlock the knowledge that is in the data that we have all in our organizations is it's just going to be a fantastic outcome. So thank you for all of you for being here today, and thanks for the folks that are watching this in person or catching the recording. Hopefully you all find it valuable.
Thank you for having us.